Thank you for that introduction. Before delving into the intricacies of the proposed end-to-end process aimed at facilitating project sourcing, allow me to provide some context on the subject of sourcing itself. Initially, I will elucidate the terminology employed within the 3D Experience platform and elucidate our understanding of sourcing. Subsequently, I'll outline the primary pain points commonly experienced by our clients, setting the stage for a brief video that encapsulates our visionary approach. Following this, we will meticulously unveil the comprehensive end-to-end process, offering a detailed exploration of its components. First, let's establish some definitions of objects within the 3D Experience platform. When engaging in a project, the initial layer we encounter is the logical item, which represents the functional requirements of a component. Next, we encounter the engineering item, EI, which defines the detailed specifications of the component. It often includes a 3D model and serves as a blueprint for designers to construct the EBOM, engineering bills of material. Following that, we have the manufacturer equivalent item, MEI. It's a commercial reference produced by a manufacturer. Each MEI possesses intrinsic qualifications, such as compliance, along with equivalent qualifications that establish its relationship with the corresponding engineering item. For instance, a single engineering item like pump generic model here may have multiple MEIs linked to it, each from a different manufacturer. Lastly, we have vendor items, which are linked to specific suppliers and encompass details such as packaging, prices, Incoterm, and more. Of particular importance here are the engineering item and the manufacturer equivalent item within this hierarchy. Now, let's delve to the concept of sourcing. Imagine we have a project, such as an electric drive, modeled through an EBOM created by designers. This EBOM comprises various engineering items. To transition from the virtual design to a tangible product, the first crucial step is determining whether to manufacture in-house or procure externally. For all parts designed for procurement, engineering item, our task is to identify suitable MEIs from suppliers and negotiate prices through the request for quotation (RFQ) process. Our objective in sourcing is to optimize this process, aiming for the best prices, quality, and sustainability while minimizing risk and reducing time to market. To achieve this optimization, we must identify relevant MEIs from trusted suppliers and negotiate the most favorable terms possible. In our sourcing operations, we categorize into distinct types of processes. Firstly, standardization management involves the discovery of MEIs, their qualifications, and assessing factors like obsolescence and potential for reuse. Next, supplier management focuses on establishing and maintaining connection with suppliers. This entails identifying potential suppliers, qualifying them, and nurturing relationships. The source-to-contract process entails the negotiation phase between our companies, buyers, and the suppliers. All three of these processes can be seamlessly managed within the 3D Experience platform. However, it's important to note that what we don't handle: procure to pay, which encompasses financial transactions, invoicing, and purchase actions typically managed within the ERP system. So now, let's address the significant challenges our customers encounter. Sourcing involves collaboration among various teams, including engineering, costing, buyers, supply chains, and compliance. The lack of data visibility due to partial digitalization is a major pain point. Often, information is scattered across multiple Excel sheets in shared folders, leading to inefficiencies and time loss. Collaboration becomes challenging due to inconsistencies in shared information. Meetings are frequent but difficult to prepare for due to this lack of coherence. Buyers often feel like they are at the end of the chain, which targets set by the project leaders and costing teams. Another issue is the transparency issue. For example, some buyers sometimes start to discuss with suppliers, but at the same time, engineering are discussing also with supplier and change the design. In response to these challenges, a complete vision is showcased in the following video presentation, and that video has convinced major CEOs in OEM automotive. So let's look at this video and then we will detail what we can propose.
The ambition of the proposed solution is to reduce the complexity and cost of compromises between program margin and time to market, occurring during the sourcing process. Purchasing as well as costing and other stakeholders in a program share the same up-to-date virtual twin environment as engineering. They are able to enrich it with their own perspectives and provide the program manager with the insight necessary to anticipate and manage the program more effectively. Let's focus on sourcing this part in blue. Before sourcing starts, purchasing is able to access the prices from Scott for similar parts sourced in the past. Based on a set of criteria such as time period and locations, a relevant average historical price is computed and compared to the target and react prices for the part. The program manager is able to see at vehicle, subsystem and part level, the gap to target to be anticipated based on historical prices. He can also see design items still open and other key parameters impacting sourcing timing. He is now equipped to manage his sourcing planning in a data-driven and dynamic way and focus upfront on risk areas. Time to launch the RFQ for our part. A collaborative space is open with each single supplier enabling to exchange documents, designs and ideas for optimization with all stakeholders in order to speed up convergence. This ensures that all parties collaborate around the same design and share the same level of information. For sourcing committee, all stakeholders benefit from a common dashboard summarizing key data points to support sourcing decisions, such as prices, NPV, risk assessment, CO2 footprint and history of design changes. All this optimization work for a new program can be leveraged to optimize costs of vehicles in serial life by identifying renegotiation opportunities. This contributes to purchasing continuous improvement cycle.
To provide a comprehensive overview of this experience, let me introduce the various personas involved. Firstly, we have the designer, responsible for crafting the e-BOM of the project. Next, we have the component engineer, tasked with standardization management, involving the discovery and qualification of MEIs. Following that, we have the sourcing manager, overseeing supplier management and the source-to-contract process. Lastly, we have the supplier representative acting as the liaison with the supplier. Our experience is segmented into different steps for exploration. We'll begin by highlighting how, even during the design phase preceding the sourcing process, we can contribute to sourcing efforts. Then we'll delve into how the sourcing manager establishes connection with suppliers. Moving forward, we'll explore the initiation of sourcing for a project, starting with an overview of the sourcing status at a given time, followed by an AI-guided component search to identify missing items. Once potential MEIs are identified, we'll discuss the qualification process before initiating negotiations with suppliers. First, let's see how the designer can support sourcing efforts from the outset. Our approach emphasizes the importance of reusing existing engineering items rather than introducing new ones for each project. To facilitate this, we provide AI tools to assist in identifying relevant existing engineering items. During the search for relevant engineering items, the focus is on reusing those with existing MEIs, as this significantly aids the sourcing process. Madam Designer, floor is yours. As a CAD designer, I'm utilizing my assembly design application to progress with my electric drive project. In this phase, I require a bracket to support the electric drive system. Rather than starting from scratch, I hope to efficiently leverage existing engineering items. Within my CAD application, I access a comprehensive part search engine directly. I can use an existing library containing a range of categorized engineering items ready for reuse. Focusing on the fixing category, I narrow down to bracket. My specifications call for a support bracket approximately 50 centimeters in length, crafted from aluminium. A particular purple bracket catches my attention as a potential fit. Before finalizing, I delve into its attributes, exploring both configuration options and engineering details. Examining its sourcing history reveals that the specific engineering item has never been sourced before, meaning that no manufacturer equivalent item has been attached to it. Therefore, further investigations could help taking a better decision. I initiate a similarity search utilizing the universal language of 3D models to scout for comparable engineering items. Among the results, I identify bracket K as a good candidate, as it is accompanied by relevant manufacturing data. Multiple manufacturer equivalent items have been qualified. With the option at hand, I seamlessly integrate the chosen bracket into my design project. I incorporate necessary mechanical interfaces to ensure precise placement within the assembly. By adopting this approach early in the design phase, I not only expedite the development process but also contribute significantly to the sourcing efficiency of the electric drive system. Now, let's see with Anat how we can manage the relation with the suppliers.
In this phase, we will explore how to establish and how to manage your supplier network by developing a supplier referential in your organization. I will start the demo by navigating and browsing through the list of approved suppliers in my network. Then we will see how to create a new supplier company, how to classify it according to the type of product it produces, according to the industry it belongs to, and according to its capabilities. I will define the relationship between my company and the supplier company, and I will rate the supplier company accordingly. Once the supplier company is approved, I can establish the communication channel between my company and the supplier company in order to provide the supplier representative an access to a dedicated portal in which he can receive and reply to messages and RFQs. Let's see now how it looks in the system. As a sourcing manager, I build and manage the suppliers' companies in my network. If we manage the address of the suppliers' companies, I can then browse the suppliers on the map to identify them by their location. Open the information panel to reveal more information about the supplier company. If I have many suppliers, I can easily filter the list based on various criteria to focus only on the relevant ones. Suppliers are organized by their buyers. If needed, I can create a new supplier company, either manually in the application or by importing the approved suppliers list from a file. Before creating a new supplier, I need to verify that this supplier doesn't exist already in my network. Only then I can create it. I enter all the relevant information in order to describe the supplier, including the relationship level and the preference. Then I set the effectivity dates to govern the relationship between the supplier company and its buyer. I can easily rate the suppliers by quality, cost, delivery, and sustainability criteria. Then I can add supplier users. Supplier user is a supplier representative that your company has invited through the 3D Experience platform to access a dedicated portal, to establish the communication channel with the supplier and invite the supplier representative to access the portal. You need to allocate a token to the supplier company. Now you can communicate with your suppliers. You can send them messages and RFQs.
Thank you, Anat. So now, let's say you are a component engineer and you want to set up a sourcing strategy for your project. First, you will check your sourcing project, make or buy vision of the project, the number of engineering items that are already qualified, the number of component introduction requests. Second, you will analyze the sourcing done, the number of MEIs that are approved, in progress, or rejected, how many times they were in this MEI are in general qualification, for example, and reveal also the suppliers that you already work with. All this information will help you to identify your next priorities, which reference that you want to qualify for source, and with which supplier you want to work with. So all this information that you need to start the sourcing process of your parts will be displayed in my 3D experience platform. So you will see that you are in the 3D experience platform, which is a real differentiator. You stay in one place and you search for your electric drive. You will drag and drop your assembly in all the applications that you need to use for your sourcing status, and you can start your analysis. You see that I have, for example, the 3D model, the product structure, and also the sourcing status for this assembly, total items, the items to buy, and I can color wash, which is another differentiator. I can color wash my KPIs, my 3D model with my KPIs. And for that, I will see the status of my KPIs directly visually in my 3D model. For example, if I click on the 3D, I can see the source qualification status that I have actually and decide which one I want to work to continue the qualification. For example, you will see that we will take the bracket until the end for our analysis. I have also information about the sourcing identification activity, and you can see more in the supplier item tab. Here you have all the information for the supplier items, and I can also color wash my 3D model. It's very interesting here because you can see that I have one reference that is obsolete and I need to rework on this part. After that, I will see, and you as a component engineer, you will want to check your suppliers, the ones, all the list of your suppliers, the ones that are active or inactive, and also the distribution by country and all the qualified source component repartition. After having all these informations in mind, you will need now to start your analysis for one engineering item and see how you can find a manufacturer equivalent item that are relevant for this part.
Having identified parts without MEIs as our priority, the next step is finding suitable suppliers and swiftly evaluating expected market prices against project targets. The following NetVibes data perspective employs AI to aid the component engineer in quickly identifying potential MEIs and suppliers using legacy data from the 3D Experience platform and from the ERP. Let's observe how the component engineer utilize this data perspective. Component engineer, I'm equipped with a powerful application that streamlines my workflow by listing engineering items alongside the corresponding manufacturer equivalent items when available. With a simple drag and drop action, I can narrow down my focus to the engineering items pertinent to my electric drive project. Each item is conveniently marked with an icon indicating whether a corresponding manufacturer equivalent item exists. This includes insights such as previous purchase orders or catalog prices. However, upon revisiting bracket for inverter A, I notice the absence of manufacturer equivalent items. In such cases, I leverage the AI-powered search functionality to explore potential suppliers. The search reveals 4 engineering items similar to bracket for inverter A, each with manufacturer equivalent item listed alongside 7 manufacturing items. By delving into each manufacturer equivalent item, I gain access to a detailed history of previous sourcing programs with different suppliers, quantities ordered, price variations, and supplier engagement levels. Additionally, I have access to cost management data, including price targets set by project managers and should cost evaluation conducted by cost managers. I can quickly check on the dedicated application for cost assessment the value put by the cost manager and see that it is coming from a should cost analysis. These values are cross-referenced with the best and average prices derived from past purchases or catalog data stored in the ERP.
I can easily see the ERP data used to compute these best and average prices. And to refine my understanding of market prices, I filter the data to include only past purchase orders from the last 2 years. All the different suppliers are listed here. I can observe their location on a map. Given that this project spans Europe and the USA, I opt to filter out suppliers from Asia while retaining only those with established partner relationships. After applying these filters, I uncover 3 manufacturer equivalent item references with relevant prices, facilitating easy comparison against my targets and computed should cost. This process helps identify inconsistencies in my target even prior to commencing the source to contract phase. To delve deeper into these true references, I conduct a comparative analysis of the best prices within the purchasing context. The first 2 references stem from past purchases, while the third is sourced from a catalog. Despite the first reference offering a more favorable Incoterm, it possesses lower qualifications in terms of quality and delivery, prompting closer consideration of the other 2. Additionally, I assess price evolution and catalog prices from these parts, alongside the relationship between price and order quantity. Consequently, I've pinpointed 2 references from 2 suppliers that align with my requirements, documenting these findings within a collaborative task to evaluate their suitability as manufacturer equivalent items. Next step is now to qualify them.
Now that I have identified my 2 manufacturer equivalent items that I can use for my engineering item, I need to go through a qualification process. For that, I will create, and you will create as a component engineer, a component request, attach these MEIs, and validate the process.
Now that I've identified 2 potential manufacturer equivalent items for this engineering item, my next step involves qualifying them using the component request application. It's a seamless process to create this request and attach the MEIs to it. The validation process entails multiple steps that require thorough examination and verification by engineering, the compliance team, and other stakeholders. This collaborative effort is seamlessly managed within the 3D Experience platform. Through this approval workflow, we not only establish general qualification, especially pertinent as we manage existing MEIs, but also assess the relevance of each MEI to the specific engineering item. As our story unfolds, at the conclusion of this authoring process, one manufacturer equivalent item receives validation, while the other is deemed invalid due to compliance reasons. Now that I have some qualified components, I let Anat explaining the source to contract process with the negotiation with supplier through the platform.
The sourcing manager gets an activity as part of the component request process, in which he is requested to interact with the suppliers and to negotiate with them the terms and cost for the bracket. As a sourcing manager, I will start by creating a new request for quotation, RFQ, based on the information provided to me in the component request. Then I will send the RFQ to the selected suppliers. Once the suppliers provide their quotes, as a sourcing manager, I can analyze their responses and negotiate with them if needed by creating a new round. Finally, I will create a vendor item to capture all the information of the bracket as it was received from the supplier in the RFQ response. As a sourcing manager, I receive a task from the component engineer in which I'm requested to initiate RFQ to outsource the bracket. The task includes all the information that I need, including the suppliers, a link to the bracket, and its technical requirements. So let's start by creating a new RFQ for the bracket. Give it a title and a description. Set a forecasted product volume. I create this RFQ based on a template. The template contains a couple of documents such as terms and conditions that will be shared with suppliers. I will add a line item which is based in our case on the bracket engineering item. So I'm searching for my bracket item and add it to the RFQ as a line item. I will add the suppliers I want to send the RFQ to. I can search for the suppliers based on different characteristics, or in our case, I know their names. So I'm just searching by name and add them to the RFQ. I don't have any specific attachments to add to this RFQ at the moment, and I'm done. I'm not submitting yet the RFQ as I want to add some additional information. It's important to provide as many details as you can on your need. The more detail you can provide, the more accurate and useful your supplier's responses will be. So I'm defining the target price for the bracket, and I'm attaching the bracket requirements. Now I'm ready to send the RFQ to the suppliers. Sometimes you want to go through an internal review process before submitting the RFQ, but for the demo purpose, I will skip this phase and I will just submit it. As a supplier user, after receiving the invitation in the mail and create my 3D Experience ID, then I can sign in to the Supplier Connect portal. I'm starting by opening the new RFQ and review all information shared with me by the buyer. I can take a look at the metadata as well as the attachments. And when I'm ready, I can start to respond to the request. As a supplier, I can add another bid for the same line item. Now I start to fill the bid's information. I'm adding the part number, which is the supplier part number, the unit price, and the lead time. In this case, both bids have the same part number, but I propose a lower price for a longer lead time. Then I'm adding my bracket technical specification as an attachment of my response. Once ready, I can perform validation to make sure all line items are answered, and then I save and submit my response back to the buyer. Once all suppliers responded to the RFQ, as the sourcing manager, I can start reviewing and analyzing the responses. The RFQ responses are available in the Responses tab. I can see in the table that one bid is below the target price, marked with a green arrow, and all others are above the target price. I can easily compare the quotes and get a visual indication about the price. I can see that the lowest quote is a little bit below the target price, which is great, and the lead time of this bid is 4 weeks. Sometimes, if you haven't reached your target price, you can decide to go for a second round with all or limited participants. A round is like a new revision of the RFQ. In our case, I will not create a new round. I got everything that I need in the first round and I'm ready to make a decision. Therefore, I start the awarding process. I decide to order 5,000 pieces from Anveri Group at a price of €15 because this is the lowest price, and this will complete the RFQ. Now, as a sourcing manager, I will create new vendor items based on the awarded bids. The vendor item represents the component that we decided to order from the vendor, and it is connected to the MEI, manufacturer equivalent item, for its engineering definition. In our case, the MEI doesn't exist yet in the platform, so I will create it together with the vendor item. Once the vendor item is created, then I can create the vendor item cost. This is how the sourcing manager captures the component pricing information. For each bid that we decided to award, we create a vendor item cost that represents the negotiated conditions in terms of packaging, price, and lead time.
Once these steps are completed, the aim is to iterate through all engineering items until the sourcing process is finalized. So, to conclude, what are the primary values inherent in our showcase approach, and how does it address key challenges? Firstly, our approach fosters seamless collaboration within the 3D Experience platform. This means that all stakeholders have access to a unified, real-time, and accurate single source of truth, promoting synergy and coherence throughout the project lifecycle. Secondly, leveraging artificial intelligence empowers the company to harness its legacy, enhancing both efficiency and effectiveness. By intelligently analyzing historical data and patterns, we optimize processes and decision-making, driving continuous improvement. Moreover, a core challenge addressed is the imperative need for agility in sourcing planning. Our solution offers proactive alerts on discrepancies and risk, enabling agile decision-making and maximizing efficiency to achieve optimal time-to-market outcomes. Lastly, our approach ensures complete traceability in collaboration and decision-making, instilling a culture of transparency. Every action and decision is meticulously documented, fostering accountability and trust within the team and across stakeholders. I would like to thank you all for your attention at this webinar. We can now go to the Q&A sessions.